evaluating, graphing, and writing piecewise functions. We're going to look at all three topics today. The first thing we're going to do is evaluating piecewise functions. So this problem would say evaluate the function for the given variables, or for the given values. So what I like to do is I like to color code my equation. So I have, this is going to be my red equation. This is going to be my blue equation. And this is going to be my green equation. So a piecewise function is when you're taking several functions, putting them together on one graph, and each function is using a certain section of the x values. They shouldn't be overlapping. Otherwise, then it's not a function. It's still a piecewise graph, but it's not a function. So for example, this means that for the x values that are less than -3, the line is -x plus 2. For the x values that are between -3 and 0, the line is y equals 7. And then for the values that are greater than or equal to 0, the values are 3x minus 1. So for each of these problems, we're going to look at the x value it's asking us to evaluate, and we're going to color code it with which domain it fits in. These are the domain restrictions for each of the equations, and our x values only fit into one of them. So here we have first problem. This is f of x equals -5. So we can go to each of our domain and see, is -5 greater than or equal to 0? No, then we're not going to use the green. Is -5 between -3 and 0? No, so we're not going to use the blue. And is -5 less than -3? The answer is yes. So this gets a red designation for us, which means we're going to plug it into let's get a pen, -x plus 2. So we plug that in, -5. So it's -5 because the x is negative, plus 2, which is 5 plus 2, which equals 7. Okay, let's look at this next one. 4. Is 4 less than -3? No, it's positive. Is 4 between -3 and 0? No. Is 4 greater than or equal to 0? Yes. So this gets a green designation. And we're going to use the green equations on it, which is 3x minus 1. So 3 times 4 minus 1 is 12 minus 1, which equals 11. So the answer for number 2 is 11. Okay, let's look at f of 1. Is 1 less than -3? No. Is 1 between -3 and 0? No. Is 1 greater than 0? Yes, 1 is greater than 0, so greater than or equal to 0. So this one gets a green designation again. Oops, let me do that in the highlighter instead. This is green, so we're going to use the green equation. The green equation is 3x minus 1. And so that's 3 times 1 minus 1, which is 3 minus 1, which equals 2. And what about 0? F of 0. Well, this one can be kind of tricky because we have 2 zeros here. Remember that less than means it's not including 0. Less than or equal to means it is including 0. So that would make 0 equal to 0. So it goes in our green equation here. So again, we have green. The green equation is 3x minus 1, which is 3 times 0 minus 1, which is 0 minus 1. Don't make that mistake. So it equals -1. Ooh, what about -1/2? Is -1/2 less than -3? No. Is -1/2 between -3 and 0? Yes, -1/2 is less than 0, but it's also greater than -3, so it fits in here for our blue equation. So this is blue. And the blue equation means no matter what x is, y equals 7. It's that horizontal piece of the line. And then lastly, f of negative 3. Is negative 3 less than negative 3? No, negative 3 is equal to negative 3, so we need to look at a different one. Is negative 3 less than or equal to negative 3? Yes. Here's where it's equal to negative 3, so again, it gets our blue equation, which means the y value doesn't change. It's always just equal to 7. So that's how you evaluate the functions, and I highly recommend getting out some highlighters, colored pencils, crayons, whatever you can, to kind of help designate the different colors, and it just helps us see it better. So let's talk about a word problem. The total cost in dollars of ordering graduation announcements is represented by the piecewise function 1.5x plus 15 if you're ordering between 0 and 25. If you're ordering between 25 and 40, the cost goes down. It's 1.25x plus 15. And if you're ordering more than 40 or more, it's x plus 15. So the cost per card goes down. And this is a real thing. I was ordering Christmas cards the other day, and you get a discount when you order more. So the price is changing when you order more, and that's why piecewise functions are a real thing. So let's designate our colors. Here's our red. Here's our blue. And here's green. And let's see, let's look at our equation here, our problem here. Determine the cost of ordering 25 announcements, then determine the cost of ordering 24 announcements. So 25 is our first number. 25 goes into this. Because 25 is less than or equal to 25, the top red one doesn't equal 25. So this means up to 24 announcements, you use this equation, but at 25, we're going to use this one. So we're going to use the blue equation for 25, but we're going to use the red equation for 24. So for C of 25, we're going to plug it into 1.25x plus 15. 1.25 times 25 plus 15. 1.25 times 25 is 31.25 plus 15 is 46.25. So this is part A. Now C of 24, we have to use the 1.5 times 24 plus 15 equation, the red one. And 15 times 24 is 36 plus 15 is 51. So it actually costs more to get 24 announcements than it did 25 announcements. For B, it says, for what number of announcements less than 25 is it financially better to purchase 25 announcements? So we know 24, it's better to buy 25. Let's look at, say, 20. C of 20. I'm just picking a number less than 25 to see if it's actually less than $40, 46.25. So that's 1.5 times 20 plus 15. 20 and half of 20 is 10, so that's 30 plus 15 is 45. So it's better to buy 20. It's cheaper to buy 20. Let's look at 21. C of 21. 1.5 times 21 plus 15. 1.5 times 21 is 31.5 plus 15, which is 46.5. So after 21, you might as well just buy 25. Okay, so after 21 announcements, after 20 announcements, it's better to buy 25. Because it's cheaper. For what number of announcements less than 40 is it financially better to purchase 40 announcements? So what is the cost of purchasing 40 announcements? 40 announcements is our green. So C of 40 is 40 plus 15, which is 55. And so let's see, let's pick maybe 30 announcements. C of 30 would be the 1.25 times 30 plus 15. And I'm doing this in my calculator, which is 37.25 plus 15, which is 52.25. So we're getting closer. I'm going to go up 2 more, thinking 2 more. So C of 32 is 1.25 times 32 plus 15. It's 40 plus 15 is $55. So if you're buying 32 announcements, it costs the same as 40 announcements. So at 32 announcements, you might as well just get 40 so you have some extra. Okay. Oh, I think okay. Graphing. Now again, I'm going to color code, but I'm also going to use, well, I'm using erasable, but you need to be using pencil. So here we have a red equation, and here we're going to have a blue equation. Our red equation is going to be only for the x values that are less than 5. Okay, so that line is going to be here. Let's put it on there. 1, 2, 3, 4, 5. Okay, this is all the places where the x values are equal to 5. So we're going to graph the first equation. I'm going to graph it in red. You're going to graph it in pencil so that we can erase the parts that we don't want. So this equation is negative x plus 5. That means my y-intercept is 5. I start on the y-axis at positive 5. There's 5. And my slope is negative 1 over 1. So I'm going to go down 1 and over 1, down 1 and over 1, and I'm going to make points. Down 1 and over 1. I'm going to draw this whole line. Now the domain tells me I only want the x values that are less than 5. So these x values are greater than 5, and these x values are less than 5. So I want to keep this side and erase this side. So we're going to erase this. And then we have to look at what our endpoint is going to be. This is just less than, so we use an open circle. And so we're going to put an open circle where our line meets our little vertical dashed line, because that's where x equals 5. And then our blue equation is x greater than or equal to, so we're going to use a solid circle. And this equation is x minus 5, so we're going to start at negative 5, and we're going to go up 1 over 1. So I'm going to start at negative 5. I'm going to go up 1 over 1, up 1 over 1. Keep going. I'm going to draw my line. And now this one says I want all x values greater than or equal to 5. So I'm going to have a solid circle where it hits my dashed line, which is this where the open circle is. And then I'm going to erase what I don't want. I want greater than 5. So these x values are greater than 5. So I want to erase what's less than 5. So I'm going to erase this part of it. And there's my graph. And it actually is an absolute value graph. Let's look at another one. Again, we'll color code it for ourselves. Here's our red. Here's our blue. Where is our line? Okay, these meet at negative 1, so I'm going to draw my little line here at negative 1. So my red line is negative 3 is my y-intercept, so this is B and this is my M. So starting at negative 3, and I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. And I'm going to connect it. And it says I want x values less than or equal to. Equal to means I'm going to have a closed circle where it meets my dashed line, where x equals negative 1. And I want, this is greater than, right? These x's are greater than 1, and these x's are less than 1. So I want to keep the less than 1 and erase the greater than 1, because this is the part of the equation that I want. And so I'm going to erase this. And there's my first piece, 2x minus 3, if x is less than or equal to -1. In my second equation, my b is 2, so start at positive 2. I'm going to go up 2 over 1 and draw my line. And here I want an open circle because it's just greater than, not greater than or equal to. Oh, that's misleading. And this is where it equals -1. And I want greater than -1, not less than -1. So I'm going to erase the less than part. I'm going to make that open circle a little bit better. And there we go. There we have it. Here's one with three equations, like we had in the first example. So we're going to make this our red equation. This one will be our blue equation, and this one will be our green equation. So this has x values less than -3, and then between -3 and 0, and then greater than 0. So we're going to end up with two of these like dashed vertical lines that I put on there last time. One at -3. Okay, well, let's leave it in this. And then one at 0. Those are where the x's are 0. So we're going to have a piece of the graph over here, we're going to have a piece in between, and then we're going to have a piece on the right. So the piece on the left, this is where x is less than -3, is -x plus 1. And that's really hard to graph if I start over here, so we're just going to graph it from the intercept, the y-axis, sorry, and then we're going to erase what we don't need. So I start at +1, because this is my y-intercept, and I'm going to go down 1 over 1. And I can draw that line. And I want an open circle because it's just greater than. So I'm going to put an open circle where it met, where x is -3 there. And here x is 0. And then I want less than -3, not greater than -3. So I'm going to erase everything to the right of my dashed line. Now this piece is between -3 and 0, so it's going to be between my two vertical lines here. It's going to be in between here. And this is f of x equals 4. That's just a horizontal line where x equals 4. And that's 1, 2, 3, 4. So it's going to be right here. That line is this way. And we have a closed circle at -3 and an open circle at 0. And I want between these two, so I want to erase these on the sides. So I'm going to erase, I'm going to erase. I'm going to make my little open circle. Oops, why do I have yellow? Make my open circle not have the line in it. And then the last part is green. It's going to start at +4 and go up 3 over 1, up 3 over 1. This line goes like this. And I'm interested in it where it's greater than 0, and it's a closed circle here. So let me close circle. This is open, and this is closed. So I want where it's greater than 0, not where it's less than 0. So I'm going to erase this piece here. So we have like an open blue circle with a closed green circle. And if you're not using colors, it's okay. The closed circle on top of the open circle just closes it, and you wouldn't see it. Okay, and lastly, we want to talk about writing piecewise functions. So let's look at the graph for number 14. We have two parts. We have parts on the left and the right of the y-axis. So that vertical line that I drew on the last graph is actually our y-axis here. And that is where x equals 0. So 0 is going to be part of my boundary. Now the first equation has a slope. Now it looks to me like it has 2 points here. One at 0, 0, which means b is 0. And it looks like it goes down 7 and over 5. So we're going to say m is negative 7/5. Down 7 and over 5. So it's negative going down, and b is 0. So this equation is y equals negative 7/5 x. And it uses the x values. What x values are these? These are x values that are less than 0. So we say for x's less than 0, because that's an open circle in the picture. And I can't, that's, oops, don't want to do that either. Now I can't undo that. Great. Okay, so that's the part of it, if this is true. Oh, there we go. I got it. So if x is greater than 0. And then the second equation here, this is a closed circle. It's equal to 3. So it's horizontal, so that's just the line y equals 3. So y equals 3 if x is greater than or equal to, because this is a closed circle, 0. And then we put it together in with this curly brace. Like basically we take off our y equals. We put a big curly brace, and that equals your y, or f of x. And that's your final answer. And so this one has all endpoints. So each of these domains, I'm going to put little lines on my axis to show where they end and begin. This is negative 3, this is 0, this is 1, and this is 5. So my first section is between negative 3 and 0. And we write that negative 3 less than or equal to, because it's a closed circle, x, which is less than or equal to, or no, just less than 0, because that's an open circle. And that equation, these are those horizontal lines, so this is at 3, so it's 3 when that is true. And then the next set is equal to 4. This one's at 4. And it's from 0 to 1. And it's both closed circles, so 0 less than or equal to x less than or equal to 1. That's in between these values. And they're closed circles, so they're both equal to. And then the last one, let's find it. Let's extend it. This would have a b of 0, because it would extend. If we extended it, it would cross at 0. And it has a slope of up 1 over 1. So the equation is 1x plus 0, and that's just x. And that's for x values that are between 1, open circle, so just greater than, or just less than, x, and less than or equal to, because it's a closed circle, 5. The writing part is hard. It's okay. Just practice writing equations of lines, and this one might be like the extra credit on the test.